All right, these are problems number 36 through 39 on our pre-calculus semester exam review. All right, and problem number 36. All right, problem number 36 says, given the points A and B, what is vector AB in component form? All right, so first of all, let's talk about, it's been a while since we've done these problems. All right, so if we say we have a point x1, y1, and a point B, x2, y2, if we want to get the vector component form, all right, of the vector AB, all right, then our answer will be, the vector will be x2 minus x1 and y2 minus y1. All right. Now, doing this problem, this particular problem, we have, and this is problem number 36, we have A is 2, -1, and B is 0, 4. All right, vector A, B, is going to be 0 minus 2, 4 minus a -1. All right, and that's going to give us -2, 5. All right, so in this case, that answer is B. All right, next problem asked, what is the magnitude and direction? Magnitude and direction of vector -6, 8. All right, to the nearest tenth of the degree. All right, so magnitude. Well, first of all, when we're talking about magnitude, all right, and let's say we use vector AB. We talk about vector AB for a second. Let's say I have some vector AB. All right, the magnitude, absolute value, we denote it by absolute value. All right, and these are the formulas that are given. We kind of changed them around during class a little bit, and we said that this is the square root of a squared plus b squared. All right, that's what we used for magnitude. All right, so if we're finding the magnitude of, put this back up here. All right, if we're finding the magnitude of vector, this is number 37, -6, 8. All right, then the magnitude of that will be the square root of -6 squared plus 8 squared. All right, that is the square root of 36 plus 64. And that's going to give us the square root of 100, which is 10. All right, now finding the direction. All right, which we're going to denote as theta. All right, two things. Now, your formulas here that are in your, these are the formulas given to you, tell you that, well, the magnitude gives you the magnitude, and it also tells you the direction of the angle is inverse tan, your u sub 2 over u sub 1, the absolute value of it, placed in the appropriate quadrant. We do this a little bit differently, all right, in my class. All right, we say that the direction is, and it's slightly different, all right, we say that it's inverse tan of B over A, no absolute values, all right, no absolute values, and then we try to denote the quadrant, all right? We go correct quadrant, all right? So Not much different. All right, we say that, all right, if this is first, second, third, and fourth, all right, we say, well, if we have theta, I'm gonna make theta blue, all right, if it's in the first quadrant, theta is the answer, all right. If it happens, let me make this, let's do this first, plus plus, this is plus minus, this is what? Minus, plus, and this is minus, minus, or negative, negative. All right, now, if it's in first quadrant, we're theta. If the value is in the second quadrant, we're theta plus 180 degrees, and that'll give you the right angle. All right, if we're in the third quadrant, we say theta plus 180 degrees also. All right, and if it's in the fourth quadrant, then whatever you get for theta, you're going to add 360 to it. All right, and that's going to give you the appropriate angle. So for number 37, it's a negative positive. Which quadrant are we in? All right, your quadrant is negative positive, so it's second quadrant, which means after we find theta initially, which is inverse tan of 8 over negative 6, all right, we're going to add 180 to it. All right, so let's do that. Let's see if we can do that. Make sure your mode is in degrees. See if we can see that on the screen a little better. Mode is in degrees. Quit. All right, we're going to go inverse tan of 8 divided by negative 6. All right, that's going to give us a negative 53.130. All right, theta is equal to negative 53.180 degrees, but we want to go plus 180. All right, so we want to add 180 to that. At 181, 180. All right, and that gives us an angle of 126.870. So theta is equal to 126.870 degrees. All right, there's 37. All right, number 38. All right, more vector work. All right, and these aren't too bad. All right, number 38 asks you to represent these two vectors. Now we're gonna try to make these vectors a little bit bigger. All right, there's u, vector u, almost. All right, and a vector v. All right, so the first thing they ask you to do is graphically represent u plus v using head to tail and parallelogram method. All right, so I'm gonna use some blue first, and we're gonna do that head to tail, where if we're doing u plus v, all right, remember we wanna go in the same direction the whole time we're doing the problem. All right, so we go u, it's about u. All right, there's u, vector u, and then in the end, to head to tail, we want to make a v. All right, so that's about u and v. It doesn't have to be precise. All right, but there's your u to v. All right, now if that's your u to v, all right, you started at u, there's your start, and here's your stop. All right, and so we want to make that vector u plus v with an arrow. All right, and there's our u, vector u plus v. All right, now it says use that parallelogram method. I tend to think that we are going to just make a parallelogram. All right, so, all right, here's you're saying u plus v this way. This way you're going to say v plus u. All right, with your arrows going in the proper direction. All right, and we have our parallelogram method. All right, number 39 asked for, vector u minus vector v. All right, and so when we have a negative vector, we want to just go in the opposite direction. All right, so if this is vector u, if this is vector v, then negative vector v would be the same distance in the opposite direction. All right, so you have v, you have negative v. All right, so let's do that. All right, vector u, again, start about right there. All right, good estimate. I'm gonna move this out the way since I have to go in that direction. All right, there's my vector u. All right, and then my vector v, minus v, or negative v, is about that length. All right, that looks like about a negative v vector. All right, so I have v, I start here, I'm going u minus v. All right, and so the resulting vector is that, and that's vector u minus vector v. All right, we're done.